Phoneme. Published by Wikipedia. A phoneme is any set of similar speech sounds that is perceptually regarded by the speakers of a language as a single basic sound, a smallest possible phonetic unit, that helps distinguish one word from another. All languages contains phonemes, and all spoken languages include both consonant and vowel phonemes. Phonemes are primarily studied under the branch of linguistics known as phonology. Examples and notation. The English words sell and set have the exact same sequence of sounds, except for being different in their final consonant sounds. Thus, SL versus saint in the International Phonetic Alphabet, a writing system that can be used to represent phonemes. Since L and T alone distinguish certain words from others, they are each examples of phonemes of the English language. Specifically, they are consonant phonemes, along with S, while is a vowel phoneme. The spelling of English does not strictly conform to its phonemes, so that the words not, nut, and nat, regardless of spelling, all share the consonant phonemes N and T, differing only by their internal vowel phonemes and A, respectively. Similarly, PT is the notation for a sequence of four phonemes, P and T, that together constitute the word pushed. Sounds that are perceived as phonemes vary by languages and dialects, so that N and are separate phonemes in English since they distinguish words like sin from sing, yet they comprise a single phoneme in some other languages, such as Spanish, in which pan and pa, for instance, are merely interpreted by Spanish speakers as regional or dialect-specific ways of pronouncing the same word. Such spoken variations of a single phoneme are known by linguists as allophones. Linguists use slashes in the IPA to transcribe phonemes but square brackets to transcribe more precise pronunciation details, including allophones. They describe this basic distinction as phonemic versus phonetic. Thus, the pronunciation patterns of tap versus tab, or pat versus bat, can be represented phonemically and are written between slashes, while nuances of exactly how a speaker pronounces P are phonetic and written between brackets, like P for the P in spit versus P for the P in pit, which in English is an aspirated allophone of P. There are many views as to exactly what phonemes are and how a given language should be analyzed in phonemic terms. Generally, a phoneme is regarded as an abstraction of a set of spoken sound variations that are nevertheless perceived as a single basic unit of sound by the ordinary native speakers of a given language. While phonemes are considered an abstract underlying representation for sound segments within words, the corresponding phonetic realizations of those phonemes, each phoneme with its various allophones, constitute the surface form that is actually uttered and heard. Allophones each have technically different articulations inside particular words or particular environments within words, yet these differences do not create any meaningful distinctions. Alternatively, at least one of those articulations could be feasibly used in all such words, with these words still being recognized as such by users of the language. An example in American English is that the sound spelled with the symbol T is usually articulated with a glottal stop. In the word cat, an alveolar flap. In dating, an alveolar plosive, T, in stick, and an aspirated alveolar plosive, T, in tie. However, American speakers perceive or hear all of these sounds as merely being allophones of a single phoneme, the one traditionally represented in the IPA as T. For computer typing purposes, systems such as X-SAMPA exist to represent IPA symbols using only ASCII characters. However, descriptions of particular languages may use different conventional symbols to represent the phonemes of those languages. For languages whose writing systems employ the phonemic principle, ordinary letters may be used to denote phonemes, although this approach is often imperfect, as pronunciations naturally shift in a language over time, rendering previous spelling systems outdated or no longer closely representative of the sounds of the language. Assignment of speech sounds to phonemes. A phoneme is a sound or a group of different sounds perceived to have the same function by speakers of the language or dialect in question. An example is the English phoneme K, which occurs in words such as cat, kit, scat, skit. Although most native speakers do not notice this, in most English dialects, the CK sounds in these words are not identical. In Kate, the sound is aspirated, but in SKL, it is unaspirated. The words, therefore, contain different speech sounds, or phones, transcribed K for the aspirated form and K for the unaspirated one. These different sounds are nonetheless considered to belong to the same phoneme, because if a speaker used one instead of the other, the meaning of the word would not change. Using the aspirated form, k, in skill might sound odd, but the word would still be recognized. By contrast, some other sounds would cause a change in meaning if substituted. For example, substitution of the sound, t, would produce the different word still, and that sound must therefore be considered to represent a different phoneme. The above shows that in English, k and k are allophones of a single phoneme, k. In some languages, however, k and k are perceived by native speakers as significantly different sounds, and substituting one for the other can change the meaning of a word. In those languages, therefore, the two sounds represent different phonemes. For example, in Icelandic, k is the first sound of kator, meaning cheerful, but k is the first sound of gator, meaning riddles. Icelandic, therefore, has two separate phonemes, k and k. Minimal pairs. A pair of words like kator and gator that differ only in one phone is called a minimal pair for the two alternative phones in question. The existence of minimal pairs is a common test to decide whether two phones represent different phonemes or are allophones of the same phoneme. To take another example, the minimal pair tip and dip illustrates that in English, t and d belong to separate phonemes, t and d. Since the words have different meanings, English speakers must be conscious of the distinction between the two sounds. Signed languages, such as American Sign Language, also have minimal pairs, differing only in one of the sign's parameters: hand shape, movement, location, palm orientation, and non-manual signal or marker. A minimal pair may exist in the signed language if the basic sign stays the same, but one of the parameters changes. However, the absence of minimal pairs for a given pair of phones does not always mean that they belong to the same phoneme. They may be so dissimilar phonetically that it is unlikely for speakers to perceive them as the same sound. For example, English has no minimal pair for the sounds h and the fact that they can be shown to be in complementary distribution could be used to argue for their being allophones of the same phoneme. However, they are so dissimilar phonetically that they are considered separate phonemes. A case like this shows that sometimes it is the systemic distinctions and not the lexical context which are decisive in establishing phonemes. This implies that the phoneme should be defined as the smallest phonological unit which is contrastive at a lexical level or distinctive at a systemic level. Phonologists have sometimes had recourse to near minimal pairs to show that speakers of the language perceive two sounds as significantly different even if no exact minimal pair exists in the lexicon. It is challenging to find a minimal pair to distinguish English from, yet it seems uncontroversial to claim that the two consonants are distinct phonemes. The two words, pressure, prar, and pleasure, plur, can serve as a near minimal pair. The reason why this is still acceptable proof of phonemehood is that there is nothing about the additional difference that can be expected to somehow condition a voicing difference for a single underlying postalveolar fricative. One can, however, find true minimal pairs for and if less common words are considered. For example, Confucian and confusion are a valid minimal pair. Suprasegmental phonemes. Besides segmental phonemes such as vowels and consonants, there are also suprasegmental features of pronunciation, which, in many languages, change the meaning of words and so are phonemic. Phonemic stress is encountered in languages such as English. For example, there are two words spelled invite, one is a verb and is stressed on the second syllable, the other is a noun and stressed on the first syllable. The position of the stress distinguishes the words and so a full phonemic specification would include indication of the position of the stress. Envat, for the verb, envat, for the noun. In other languages, such as French, word stress cannot have this function and so it is not phonemic. Phonemic tones are found in languages such as Mandarin Chinese in which a given syllable can have 5 different tonal pronunciations. The tone phonemes in such languages are sometimes called tonemes. Languages such as English do not have phonemic tone, but they use intonation for functions such as emphasis and attitude. Distribution of allophones. When a phoneme has more than one allophone, the one actually heard at a given occurrence of that phoneme may be dependent on the phonetic environment. Allophones that normally cannot appear in the same environment are said to be in complementary distribution. In other cases, the choice of allophone may be dependent on the individual speaker or other unpredictable factors. Such allophones are said to be in free variation, but allophones are still selected in a specific phonetic context, not the other way around. Background and related ideas. The term phoneme was reportedly first used by a Dufriche Deschanets in 1873, but it referred only to a speech sound. The term phoneme as an abstraction was developed by the Polish linguist Jan Baudouin de Courtenay and his student Mikołaj Kraszewski during 1875 to 1895. The term used by these two was phonema, the basic unit of what they called psychophonetics. Daniel Jones became the first linguist in the Western world to use the term phoneme in its current sense, employing the word in his article, The Phonetic Structure of the Szechwana Language. The concept of the phoneme was then elaborated in the works of Nikolai Trubetskoy and others of the Prague school, and in those of structuralists like Ferdinand de Saussure, Edward Sapir, and Leonard Bloomfield. Some structuralists rejected the idea of a cognitive or psycholinguistic function for the phoneme. Later, it was used and redefined in generative linguistics, most famously by Noam Chomsky and Maurice Halley, and remains central to many accounts of the development of modern phonology. As a theoretical concept or model, though, it has been supplemented and even replaced by others. Some linguists propose that phonemes may be further decomposable into features, such features being the true minimal constituents of language. Features overlap each other in time, as do suprasegmental phonemes in oral language and many phonemes in sign languages. Features could be characterized in different ways. Jakobson and colleagues defined them in acoustic terms. Chomsky and Halley used a predominantly articulatory basis, though retaining some acoustic features, while Ladefoged's system is a purely articulatory system apart from the use of the acoustic term, sibilant. In the description of some languages, the term chroneme has been used to indicate contrastive length or duration of phonemes. In languages in which tones are phonemic, the tone phonemes may be called tonemes. Though not all scholars working on such languages use these terms, they are by no means obsolete. By analogy with the phoneme, linguists have proposed other sorts of underlying objects, giving them names with the suffix -eme, such as morpheme and grapheme. These are sometimes called emic units. The latter term was first used by Kenneth Pike, who also generalized the concepts of emic and etic description to applications outside linguistics. Restrictions on occurrence. Languages do not generally allow words or syllables to be built of any arbitrary sequences of phonemes. There are phonotactic restrictions on which sequences of phonemes are possible and in which environments certain phonemes can occur. Phonemes that are significantly limited by such restrictions may be called restricted phonemes. In English, examples of such restrictions include the following. As in sing, occurs only at the end of a syllable, never at the beginning. H occurs only at the beginning of a syllable, never at the end. In non-rhotic dialects, can occur immediately only before a vowel, never before a consonant. With and j, occur only before a vowel, never at the end of a syllable. Some phonotactic restrictions can alternatively be analyzed as cases of neutralization. See neutralization and archiphonemes below, particularly the example of the occurrence of the three English nasals before stops. Biuniqueness. Biuniqueness is a requirement of classic structuralist phonemics. It means that a given phone, wherever it occurs, must unambiguously be assigned to one and only one phoneme. In other words, the mapping between phones and phonemes is required to be many to one rather than many to many. The notion of biuniqueness was controversial among some pre-generative linguists and was prominently challenged by Maurice Halley and Noam Chomsky in the late 1950s and early 1960s. An example of the problems arising from the biuniqueness requirement is provided by the phenomenon of flapping in North American English. This may cause either T or D to be realized with the phone. For example, the same flap sound may be heard in the words hitting and bidding, although it is intended to realize the phoneme T in the first word and D in the second. This appears to contradict biuniqueness. For further discussion of such cases, see the next section. Neutralization and archiphonemes. Phonemes that are contrastive in certain environments may not be contrastive in all environments. In the environments where they do not contrast, the contrast is said to be neutralized. In these positions it may become less clear which phoneme a given phone represents. Absolute neutralization is a phenomenon in which a segment of the underlying representation is not realized in any of its phonetic representations. The term was introduced by Paul Kaparsky, and contrasts with contextual neutralization where some phonemes are not contrastive in certain environments. Some phonologists prefer not to specify a unique phoneme in such cases, since to do so would mean providing redundant or even arbitrary information. Instead, they use the technique of underspecification. An archiphone me is an object sometimes used to represent an underspecified phoneme. An example of neutralization is provided by the Russian vowels a and o. These phonemes are contrasting in stressed syllables, but in unstressed syllables the contrast is lost, since both are reduced to the same sound, usually. In order to assign such an instance of to one of the phonemes a and o, it is necessary to consider morphological factors. In some cases even this may not provide an unambiguous answer. A description using the approach of underspecification would not attempt to assign to a specific phoneme in some or all of these cases, although it might be assigned to an archiphone me, written something like a, which reflects the two neutralized phonemes in this position, or a, o, reflecting its unmerged values. A somewhat different example is found in English, with the 3 nasal phonemes per meter, n. In word final position these all contrast, as shown by the minimal triplet sum, sm, sun, sn, sung, s. However, before a stop such as p, t, k, only one of the nasals is possible in any given position. Per meter, before p, n, before t, or d, and before k, as in limp, lint, link. The nasals are therefore not contrastive in these environments, and according to some theorists this makes it inappropriate to assign the nasal phones heard here to any one of the phonemes. Instead they may analyze these phonemes as belonging to a single archiphone me, written something like n, and state the underlying representations of limp, lint, link to be lnep, lant, link. This latter type of analysis is often associated with Nikolai Trubetskoy of the Prague school. Archiphonemes are often notated with a capital letter within double virgules or pipes, as with the examples a and n given above. Other ways the second of these has been notated include mn, m, n, and n. Another example from English, but this time involving complete phonetic convergence as in the Russian example, is the flapping of t and d in some American English. Here the words betting and betting might both be pronounced b. Under the generative grammar theory of linguistics, if a speaker applies such flapping consistently, morphological evidence would reveal which phoneme the flap represents, once it is known which morpheme is being used. However, other theorists would prefer not to make such a determination, and simply assign the flap in both cases to a single archiphone me, written d. Further mergers in English are plosives after s, where p, t, k conflate with b, d, as suggested by the alternative spellings sketty and esgetty. That is, there is no particular reason to transcribe spin as sbn, rather than as sbeen, other than its historical development, and it might be less ambiguously transcribed sbeen. Morphophonemes. A morphophoneme is a theoretical unit at a deeper level of abstraction than traditional phonemes, and is taken to be a unit from which morphemes are built up. A morphophoneme within a morpheme can be expressed in different ways in different allomorphs of that morpheme. For example, the English plural morpheme s appearing in words such as cats and dogs can be considered to be a single morphophoneme, which might be transcribed z or z, and which is realized phonemically as s, after most voiceless consonants, and as z in other cases. Numbers of phonemes in different languages. All known languages use only a small subset of the many possible sounds that the human speech organs can produce, and, because of allophony, the number of distinct phonemes will generally be smaller than the number of identifiably different sounds. Different languages vary considerably in the number of phonemes they have in their systems. The total phonemic inventory in languages varies from as few as 9 to 11 in Piraha and 11 in Rodokas to as many as 141 in Shu. The number of phonemically distinct vowels can be as low as 2, as in Ubik and Arrernte. At the other extreme, the Bantu language Ngwe has 14 vowel qualities, 12 of which may occur long or short, making 26 oral vowels, plus 6 nasalized vowels, long and short, making a total of 38 vowels, while ko achieves 31 pure vowels, not counting its additional variation by vowel length, by varying the phonation. As regards consonant phonemes, Puinav and the Papuan language Tawad each have just 7, and Rodokas has only 6. Ko, on the other hand, has somewhere around 77, and Ubik 81. The English language uses a rather large set of 13 to 21 vowel phonemes, including diphthongs, although its 22 to 26 consonants are close to average. Across all languages, the average number of consonant phonemes per language is about 22, while the average number of vowel phonemes is about 8. Some languages, such as French, have no phonemic tone or stress, while Cantonese and several of the Kam-Sui languages have 6 to 9 tones, and the Kam-Sui Dong language has 9 to 15 tones by the same measure. One of the Kru languages, Wobe, has been claimed to have 14, though this is disputed. The most common vowel system consists of the 5 vowels I, E, A, O, U. The most common consonants are P, T, K, per meter, N. Relatively few languages lack any of these consonants, although it does happen. For example, Arabic lacks P, Standard Hawaiian lacks T, Mohawk and Tlingit lack P, and per meter. Hoopa lacks both P, and a simple K, colloquial Samoan lacks T, and N, while Rodokas and Quileute lack per meter, and N. The non-uniqueness of phonemic solutions. During the development of phoneme theory in the mid-20th century, phonologists were concerned not only with the procedures and principles involved in producing a phonemic analysis of the sounds of a given language, but also with the reality or uniqueness of the phonemic solution. These were central concerns of phonology. Some writers took the position expressed by Kenneth Pike. There is only one accurate phonemic analysis for a given set of data, while others believed that different analyses, equally valid, could be made for the same data. Yuan Ren Chao, in his article, The Non-Uniqueness of Phonemic Solutions of Phonetic Systems, stated, given the sounds of a language, there are usually more than one possible way of reducing them to a set of phonemes, and these different systems or solutions are not simply correct or incorrect, but may be regarded only as being good or bad for various purposes. The linguist F.W. Householder referred to this argument within linguistics as God's truth versus hocus pocus. Different analyses of the English vowel system may be used to illustrate this. The article English Phonology states that English has a particularly large number of vowel phonemes, and that there are 20 vowel phonemes in received pronunciation, 14 to 16 in General American and 20 to 21 in Australian English. Although these figures are often quoted as fact, they actually reflect just one of many possible analyses, and later in the English Phonology article an alternative analysis is suggested in which some diphthongs and long vowels may be interpreted as comprising a short vowel linked to either j or with. The fullest exposition of this approach is found in Traeger and Smith, where all long vowels and diphthongs are made up of a short vowel combined with either j, with or h, each comprising 2 phonemes. The transcription for the vowel normally transcribed, a, would instead be aj, a, would be and would be or ar, in a rhotic accent if there is an r in the spelling. It is also possible to treat English long vowels and diphthongs as combinations of 2 vowel phonemes, with long vowels treated as a sequence of 2 short vowels, so that pom would be represented as pom. English can thus be said to have around 7 vowel phonemes, or even 6 if schwa were treated as an allophone of or of other short vowels. In the same period there was disagreement about the correct basis for a phonemic analysis. The structuralist position was that the analysis should be made purely on the basis of the sound elements and their distribution, with no reference to extraneous factors such as grammar, morphology or the intuitions of the native speaker. This position is strongly associated with Leonard Bloomfield. Zelig-Harris claimed that it is possible to discover the phonemes of a language purely by examining the distribution of phonetic segments. Referring to mentalistic definitions of the phoneme, Twaddle stated, "Such a definition is invalid because we have no right to guess about the linguistic workings of an inaccessible mind, and we can secure no advantage from such guesses. The linguistic processes of the mind, as such, are quite simply unobservable, and introspection about linguistic processes is notoriously a fire in a wooden stove." This approach was opposed to that of Edward Sapir, who gave an important role to native speakers' intuitions about where a particular sound or group of sounds fitted into a pattern. Using English as an example, Sapper argued that, despite the superficial appearance that this sound belongs to a group of 3 nasal consonant phonemes, native speakers feel that the velar nasal is really the sequence. The theory of generative phonology, which emerged in the 1960s, explicitly rejected the structuralist approach to phonology and favored the mentalistic or cognitive view of Sapper. These topics are discussed further in English Phonology #controversial issues. Correspondence between letters and phonemes. Phonemes are considered to be the basis for alphabetic writing systems. In such systems, the written symbols represent, in principle, the phonemes of the language being written. This is most obviously the case when the alphabet was invented with a particular language in mind. For example, the Latin alphabet was devised for classical Latin, and therefore the Latin of that period enjoyed a near one-to-one correspondence between phonemes and graphemes in most cases, though the devisers of the alphabet chose not to represent the phonemic effect of vowel length. However, because changes in the spoken language are often not accompanied by changes in the established orthography, the correspondence between spelling and pronunciation in a given language may be highly distorted. This is the case with English, for example. The correspondence between symbols and phonemes in alphabetic writing systems is not necessarily a one-to-one correspondence. A phoneme might be represented by a combination of 2 or more letters, like sh in English or sch in German. Also, a single letter may represent 2 phonemes, as in English x representing gz, or per kilosecond. There may also exist spelling, pronunciation rules that further complicate the correspondence of letters to phonemes, although they need not affect the ability to predict the pronunciation from the spelling and vice versa, provided the rules are consistent. In sign languages. Sign language phonemes are bundles of articulation features. Stokoe was the first scholar to describe the phonemic system of ASL. He identified the bundles tab, des, and sig. Some researchers also discern ori, facial expression or mouthing. Just as with spoken languages, when features are combined, they create phonemes. As in spoken languages, sign languages have minimal pairs which differ in only one phoneme. For instance, the ASL signs for father and mother differ minimally with respect to location, while hand shape and movement are identical. Location is thus contrastive. Stokoe's terminology and notation system are no longer used by researchers to describe the phonemes of sign languages. William Stokoe's research, while still considered seminal, has been found not to characterize American Sign Language or other sign languages sufficiently. For instance, non-manual features are not included in Stokoe's classification. More sophisticated models of sign language phonology have since been proposed by Brentari, Sandler, and van der Kuij. Cherime. Cherology and cherime are synonyms of phonology and phoneme previously used in the study of sign languages. A cherime, as the basic unit of sign communication, is functionally and psychologically equivalent to the phonemes of oral languages, and has been replaced by that term in the academic literature. Cherology, as the study of cherimes in language, is thus equivalent to phonology. The terms are not in use anymore. Instead, the terms phonology and phoneme are used to stress the linguistic similarities between signed and spoken languages. The terms were coined in 1960 by William Stokoe at Gallaudet University to describe sign languages as true and full languages. Once a controversial idea, the position is now universally accepted in linguistics. Stokoe's terminology, however, has been largely abandoned.